Hi, it's Jan Beta, and today I'm wearing my protective gloves because we're going to work on an A501 Amiga 500 memory expansion today. These are the classic memory expansions, 512K of extra RAM for the Amiga 500 that were released together with the machine in 1987 by Commodore. And these famously have a real-time clock that has a rechargeable NiCad battery on the board under this RF shield. And these batteries, pretty much all of them, have leaked in the meantime since 1987 when this was probably made. And I can already see some corrosion here on this RF shielding can. And the plan for today is to A, get this out of this RF can, and B, try to resurrect it and of course remove the battery and any damage that has caused over the years. This may get a bit dirty, so I'm wearing gloves. And of course you don't want to get in touch with any of the chemicals that have leaked from the battery. I don't really know why I didn't crack this open before. I think I had this in my parts bin, in my Amiga spares bin for quite some years now. I kind of forgot about this one. I had a couple of these that came with random Amiga 500 auctions I won on eBay and things like that. We're going to take a look at this. Better late than never, I guess. It might be too late for this one. It seems pretty compromised, but yeah. Let's see what we can do. This might potentially be fun to watch for you, at least. Not really fun for me, but yeah. Let's see if we can fix this, at least partially. These cans are, unfortunately, they are soldered shut by Commodore, even though there's a battery in there, which is not very nice of them, but all the ones I've seen are soldered shut. So we're going to have to remove the solder in order to get to the innards of this thing. Let's try that. I fired up my desoldering station, got some fresh solder here, some solder wick, solder pump. I think we're probably going to need all of them. Of course, my regular soldering iron is also powered up. So yeah, first thing, I'm going to add some liquid flux here. And the corrosion doesn't really help desoldering, actually. So I'm going to add some fresh solder here. Let's see. And of course this is a huge metal can, basically. It needs quite some heat. But I don't think it's thermally connected to the circuit board, actually, so can apply quite some heat without risking damaging the circuit. Okay. That one worked rather well. Okay, the rest of this is probably going to be prying with a screwdriver, more or less, and heating it up at the same time. There we go. I think that might have done it. Yay! Okay, bottom side of the PCB doesn't look as bad as I expected, but it still looks pretty bad. There's this insulation sheet here. You can see some rust spots on that. The bottom shielding is actually quite nice still. So, and this whole thing should just come apart now. Yeah, there's our Varta, and this side of the shielding is a bit more compromised. And so is the circuit board. Not sure if this is fixable. So yeah, this is actually a version of this from 1988. Cake is the nickname for this, the internal name. And you can see our Varta 3 volts rechargeable NiCad battery on here. And the leakage is actually all this stuff here. And the little bubbly stuff you see here, and the green stuff you see in the connector here, The green stuff you see on top here, and there's a piece of tape. It's meant to insulate it against the shielding, I think. This looks pretty compromised. I am going to remove the battery first, and I doubt that we can make the real-time clock work. That is this portion here. And also the silk screen comes off. Yeah, but the memory expansion, we might be able to make that work, at least. The older versions of these had, I think, 8 smaller memory chips. These are the RAM chips on this. This is the clock chip, and this whole portion here is for the real-time clock, the battery buffered clock. Not sure if that's worth saving, but we can at least try to save the rest of this and use it as a 512K RAM expansion, which is the more useful part for a standard Amiga 500 anyway. So Commodore A501 revision 6C, 512 kilobytes plus RAM expansion. Yay! So yeah, we're going to remove the battery with a pair of pliers, I guess. Or maybe we can even desolder it nicely. Let's try that. So I'm going to put some fresh solder on this. Okay, battery desoldered. And this is what this looks like. It doesn't look that bad because everything leaked on the board, basically. So this doesn't have much signs of corrosion on itself. Definitely spilled its innards over all of this. So yeah, the silk screen is super compromised. It's just going to rub off, I think. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also offer CNC machining, 3D printing, sheet metal fabrication, injection molding, basically everything the tinkerer needs. Pricing is super reasonable, delivery is fast, and the service is excellent. And they also have replacement PCBs for Amiga memory expansions in their repertoire. So if you want to make your own, you can just look at the open projects on PCBWay.com. The link is in the video description. I highly recommend checking that out. Back to our corroded A501. I might just want to go and scrape that stuff off, which is just, yeah, it's just coming off. This is what happens to the circuit board under the silk screen here. This is what this looks like, all the corrosion. Wow. Okay, I'm going to have to clean this very, very thoroughly. And because the battery leakage is alkaline, we're going to have to use something to neutralize that, like vinegar or lemon juice. And yeah, I'm going to remove what I can, what just comes off here. And then we're going to bathe this in white vinegar. Look at that. That looks terrible. This might just be the worst case of corrosion that I've seen so far during my repairs. Yeah, but fortunately enough, I think the RAM expansion part of this is pretty much unaffected. There's some corrosion on some of these little capacitors here, but most of it is on the part that is the real-time clock that we are probably not going to be able to save because some of the connections here have probably really badly corroded. At least we're going to have a memory expansion, maybe, if I can somewhat clean this up to an extent that it is usable again. Let's get out some white vinegar and clean this. Yeah, chemically the leakage is alkaline, basic, so you need something acidic to neutralize that. You can use lemon juice, or what I like to use is white vinegar. We are going to see this bubbling up as soon as I pour white vinegar over it because of the chemical neutralizing reaction. So the leakage should be neutralized after that treatment, and then we're going to take a look at some other fixes. And of course you want to clean off the acid from this, because otherwise it's going to continue corroding the board just from the other side of the chemical spectrum. So we want to neutralize the corrosion, then clean this with some distilled water and alcohol, and then try to make it work. That's the order of operations. So, plastic container, this goes in there. White vinegar, just standard white vinegar from my kitchen, goes on there. It should bubble up. There we go. It's all nice and bubbly. And I'm just going to basically bathe this thing in white vinegar. And just let it sit there for a couple of minutes. Probably not the best for the chips and such, but this is at least going to get rid of the alkaline battery leakage there. Just realized that naming this cake is kind of strangely appropriate. Looks like one of those rainbow cakes, but all the colors are green. Yeah, I'm going to leave this in here for half an hour or so until the reaction is finished, and then we're going to wash this in the sink, and then we're going to give it another wash with some alcohol. So my little cake soaked for half an hour now in vinegar, and you can already see that the green stuff is coming off there. Sorry about the lighting, I'm in my kitchen. This is now going to be scrubbed with an old toothbrush and a lot of dish soap. And then I'm going to finish up with some distilled water and some isopropanol. And we should be able to get rid of the whole green stuff here eventually. Hopefully. At least we neutralized the alkaline at this point, I'm pretty sure. Yeah, I'm now going to leave this to dry. There's still some spots where we need some more physical force. This green spot here, we need to remove that eventually, but going to let it dry for now. Cleaned it with alcohol as the final pass, so the water should be displaced, and maybe we can make this work. So it's a couple of days later, and I did some research about our compromised RAM expansion, and this is what it looks like now after the initial cleaning and neutralizing pass. This whole portion of the board is completely gone, basically. That's where the real-time clock chip and all the components that are connected to that are. And I don't think we can resurrect that in any reasonable way. We could put a lot of botch wires on here, but most of the connections on the top side of the PCB are completely gone. And I looked up the schematics for this RAM expansion, and I found quite some interesting things, which I'm going to share with you. So here's the schematics. I'm going to link that in the video description as well, so you can look it up yourself. This is our real-time clock, and it's basically the clock chip and some components that are needed by that, like an oscillator, a clock crystal. It's not an oscillator, it's just a crystal. Some capacitors and things like that are just used for the real-time clock. And the real-time power, that's the interesting part. Didn't know that at all. It's actually powered by the 12-volt rail. The clock chip itself operates on 2 to 7 volts according to the datasheet. This is the classic Oki 6242 clock chip. That's the one that's on the actual device we have. That operates on 2 to 7 volts, and the voltage is actually provided by the 12-volt rail and brought down to an acceptable voltage with a couple of resistors and diodes that are responsible for that. And if a battery is present on the board, actually the voltage is brought down even more, so this gets the operating voltage. If you just remove the battery without replacing it, this might get a too high voltage, so it's not going to be recognized by the system. If you replace the battery, you are going to get the operating voltage this needs from the 12-volt rail. You can replace the battery with a coin cell. There's many videos about that. I did one myself. In that case, you are going to have to replace the R911 resistor, which is the one directly hooked up to the 12-volt rail here, 470 ohms resistor. You're going to have to replace that with the diode so that the charging of the battery is no longer done because the coin cell is non-rechargeable. And putting a lithium rechargeable coin cell in there would require a whole other charging circuit because it's a whole different technology, as you probably know. So the way to do that is to remove R911 and put a diode in to cut the voltage supply to the coin cell, and the coin cell is going to be connected more or less directly to our real-time clock chip and provides 3 volts to that as long as it lasts, just completely cut off from the power from the Amiga. What I'm going to do, I think, because we need a lot of cleanup on this board anyway, I'm going to remove all these components from the board so we don't have a clock chip. It would not be recognized by the system probably at this stage, but I think we can at least make the RAM expansion work and just remove all the components that we don't need. We need a lot more cleanup as well, but I might as well just remove the components that we don't need from the board before I do that to have more access to the actual board. That's the plan moving forward. And then we're going to see if our RAM expansion actually works or if this whole exercise was pointless. Even more pointless than it is anyway, because as I said, you can get replacements for these really easily. There's modern implementations of RAM expansions for the Amiga that are not expensive at all. You can buy replicas of these boards for all kinds of A501 revisions and just remove the chips from this and the components and put them on the new boards. But I'm not going to do that, because where's the fun in that? What I am going to do is to go through these schematics and just remove all the components that are listed in the real-time clock section here. Including the clock chip, which I'm probably going to be able to use for repairs of one of these RAM expansions, or use it in an Amiga 500 Plus, which I think had this whole circuit on board. It would be enough to just remove R911 and we would cut power to the whole clock section entirely, I think, as far as I can interpret the schematics, but I'm just going to remove all of this just to have some spare parts and to be able to work on the RAM expansion itself. Funnily enough, the traces that go to the actual RAM expansion part of this are intact mostly, as far as I can see. There's just some corrosion around the perimeter of the board and in the clock section. Yeah, I'm just going to do this one component at a time, starting with the chip, I guess, and then do the final cleanup of this, and maybe we're going to reseal the board afterwards. We are also going to have to do some more cleaning on the connector because some of the pins are starting to corrode. It's not that bad, but there's some green stuff in the actual contacts here, which this side of the contacts I don't think we need really. We need this side mostly, so that's fortunate. Most of the corrosion is here. So chances are we're just going to make the RAM expansion work again. We'll see. I'm going to add some fresh solder to the components in question. Maybe this is a stupid idea, I'm not sure. But for science. And for once I don't have to worry about breaking the board. So I think I removed the whole real-time clock section, yeah, because it was compromised. Look at these traces under the chip here. Some of these are just gone completely, so this wouldn't have worked very well. Anyway, even if we patched up the traces that are visible. I'm going to do some more cleanup here. And yeah, these two capacitors that are in the area are also used for decoupling the power supply to the RAM expansion part of this. So these are going to be necessary for this to work, the RAM expansion part. I'm not sure if the connections are all there. I'm going to check that, but it looks like it is forked off on the bottom side, which is intact. So should be good. I'm just going to do some more cleanup here. It's going to be a bit tedious. I'm going to use a glass fiber pen and just remove everything that I can see in terms of corrosion here that's left. So here's where we are. I used isopropanol to wash away the dust that I scraped off with my fiberglass pen here. Glass fiber pen. I still don't know what the correct term is, probably both. Yeah, there's some corrosion on the parameter on the backside as well, as you can see. Or there was some corrosion. I removed most of it at this point. Still going to let this dry and have another look. But I think the bulk of it should be gone now. And most of the connections to our RAM are still good, it seems. So chances are that this is just going to work again. I'm going to have to clean the connector though. As I said, I'm just going to use some component lag to get in there, I think. I think I cleaned everything that I can. I am going to let this dry and then we're going to put it in an actual Amiga and see what it does. Maybe it just works still. I can see some traces here that might have breaks that were close to where most of the corrosion happened here, but we're going to be able to patch that up in case it doesn't work. We'll see. So I brought out my Amiga 500 in the crystal clear case. We're going to stick this in there and see if it works with that in place. Okay, let's try this with the memory expansion. Chances are this is going to turn on. There's also a 50% chance that this is not even going to turn on or going to damage the Amiga, but I'm pretty sure it won't damage the Amiga because we removed everything that could cause a short circuit or something like that. Let's see. Fingers crossed. Power LED comes on. Hey! And the Amiga fired up. So we're going to have to test the memory. And I think I'm just going to use the Amiga test kit disk that I should have handy somewhere. If I was organized. Let me find that. Got it. Let's see. Okay, let's test the memory. 1 megabyte total memory detected. That's the 50.5 megabytes chip RAM on board and 0.5 megabytes in the memory expansion. So we should be able to test our memory. Let's see. This takes a while, and I'm going to let it run for a while and report back, I guess. It's also already on round 2. So the memory expansion seems to work fine. Real-time clock doesn't, but that's to be expected if we remove all the components that are in any way related to the real-time clock. Yeah, this seems to have been a success, at least the memory expansion part, which is by far the more important part if you just want an Amiga 500 to play with. That works. As I said repeatedly, this is a really unnecessary exercise that I just did. But as you can see, the memory test is still running on round 7 at the moment. So the memory expansion works fine. That's usually the case with these A501s. The battery is close to the clock circuitry, of course, and if you remove that and remove all the corrosion, you usually get a working memory expansion at least, because those traces are further away from the battery and usually are not affected that much by the corrosion. Point proven, I guess. And this is going to be useful to me, because this Amiga didn't have a memory expansion in it, and now it has. Yeah, no clock detected, of course, because there's no longer a clock chip on the memory expansion and everything that is related to it is removed. What I do want to do, though, is to replace the remaining 2 electrolytic capacitors on our little memory expansion and then seal the PCB after another round of cleaning. Just wanted to make sure this worked the way I intended it to work after our corrosion repair or removal, more or less. Not much in terms of repairing, really. Yeah, I'm going to replace the capacitors, seal the board off, and then call it a day, I guess. I am a bit surprised myself that this works still, but it does. Yeah, the 2 remaining capacitors are for decoupling the 5-volt rail, which is also used for the memory expansion itself. So we are going to recap this in any case, because these capacitors are from 1988 and they're not very good anymore, I guess. They do still work, but I kind of want this to be a finished product. So I'm using this nasty stuff, which is Kontakt Chemie Kontakt LR. Leiterplattenreiniger, which means PCB cleaner. And yeah, it's pretty effective. It has a little brush here that you can use to spray stuff and scrub it at the same time. And the PCBs usually come out really clean after that treatment. Should have probably worn gloves for this, but yeah, you get the idea. So now that we have cleaned this, I'm going to seal it with a kind of, this is conformal coating basically. This is a protective lacquer for circuit boards. I'm going to tape off the connector because we don't want to seal that off. But the rest of it is just going to be covered in a plastic spray paint basically. This is pretty much overkill, but I have this stuff and we're going to do it. This is even more stinky than the other stuff, so I'm going to have my carbon filter running here next to it. Should wear gloves for this, I guess. Yeah, and then that is going to dry. And here's the final result, hopefully, in case this still works. It looks shiny, it got its conformal coating. All this stuff should be sealed off now. You can see that there's a layer of lacquer on there. That's what this is, basically, acrylic lacquer. So this should be nicely protected against weather and moisture and things like that now. But also we have sealed off the circuit board itself, just like with solder mask. And this stuff you can solder through it so it melts and you can still desolder components and solder new components in. Ideally, I've never actually tried that, but this is professional use stuff, so we should be good. And there we go. Still shows up as 512K chip and 512K slow memory, which is what we expected. See if the RAM test still passes. Yeah, I guess we fixed this, or at least preserved it. Yeah, and I started up Turrican 2, which I think requires 1 megabyte to run, But we ran the RAM test anyway, and the memory expansion seems to work fine. So should this work with 512K Amiga? Still, I have to end every Amiga video with playing Turrican, basically. And in this case, Turrican 2. Hope this was informative and maybe a bit entertaining. As I said repeatedly, this was kind of a pointless exercise because you can get these memory expansions really inexpensively. Newly produced ones these days for the Amiga 500 are available everywhere. You can make your own from pre-configured PCBs and things like that. There's a plethora of options to not go through this process, but I still wanted to try if I could preserve this, and it is a useful piece of hardware. I am going to use this in this Amiga, which didn't have a memory expansion before, so it's super useful for me, and it seems to work fine, except for the real-time clock, which I won't use much anyway. Thanks very much for your time, thanks for watching, thanks for your thumbs and your comments and your subscriptions, which are pretty important. So if you aren't subscribed to this channel and like what I do, please hit the subscribe button. It really, really helps with that kind of weird algorithm that YouTube put into its guts. Special thanks, as usual, to everybody who supports me on Patreon and on Ko-fi and on the YouTube channel memberships page and elsewhere. The links to that are in the video description. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.